And I'm going to start really from the top with what was the vision. It was the founding vision, and what have we stayed true to as we've gone through. When we started in 2010, this whole thing called SDS, software defined storage, that wasn't an acronym back then. But as it turns out, that's what we really did build. So from the beginning, we had these intertwined goals of a software defined, like high value storage that's wrapped in tin for us, because a market we're going, needs appliances. But also this ease of use in this management system that ties it all together. And that has remained unchanged through the whole thing. The whole goal, to just keep reiterating, eliminate complexity, make it plug and play, and cover a bunch of those next gen features that Doug talked about. Deduplication, snapshots, scale out, simple, powerful, and protected. Also, the key realization I think a lot of the other object storage vendors haven't attacked a market for is, in order to really address the legacy apps. You'll have a lot of object storage vendors and analysts like you guys ask, what's hindering the adoption of object storage? And it's really, in my view, it's because we haven't thought, most of the vendors haven't really thought about how to really tightly integrate the NAS features so that you can do all those workloads. And what does that really mean? It really means eliminate complexity, right? There shouldn't be separate metadata servers and data servers, bolted on NAS gateways on top of it, as an afterthought. And really, with the addition of a node or a drive, you should be able to, scale all three axes of storage, performance, reliability,
challenge with object storage,
capacity.
We were in a prior discussion, we won't discuss it, but how do you overwrite the objects? In a file system, you can overwrite files anytime you want.
Exactly, yep.
Objects typically are very persistent.
They really are. I'll give you kind of the flip answer to that. The first is deleting something's the most expensive thing you can ever do. So why would you want to delete an object anyway? With storage being so cheap. The real answer is that because for many workloads, deletes rare compared to the writes. We spend an extra effort. We can actually spend an extra effort in the software to actually optimize for the other case, which is object stores are good at, and then spend the extra compute cycles when it comes time to delete to actually go find the stuff that's, because of deduplication and because of so on, is shared, that you can actually delete.
I think it's also important to be clear that in your system, a file is not an object. A file becomes an object depending on its size.
Exactly, yeah. So we don't take one file per one object like a lot of object stores do. They're not really files, right? But they're, the whole thing is one object. So we divide each large file into many small files, or many small objects, sorry. And that makes it much easier to do deduplication, and so we get a better dedupe ratio. We do that inline, and then it also enables us when one of our patent areas, by the way, down here is garbage collection, and so we're pushing next gen technology into how do you actually go and find that garbage that you don't need anymore, and how do you do that quickly and efficiently, and so that's a patent area for us. Then, from an intellectual property, we really are covering this whole idea of cloud management and network management of storage. The distributed file systems, how do you build a POSIX compliant file system tightly coupled to an object store, and then the object store technology itself. So we basically own the stack everywhere from the protocol, from right below the protocol, all the way to the data that lands on the drives. And I'll talk about that quite a bit. Why did we take this big amount of work to do? And really it's because the other folks weren't doing it, and as a result, we're running up against some problems and some issues they weren't addressing. And these have to do mostly at a very high level with this area, right? Is benefits that you get by doing this are this really ability to scale out NAS and object clusters across any kind of media the way we've been talking about. HDDs and SSDs and shingle drives. There's a question about shingle drives earlier. I'll talk about them a little bit more later on as well.
Oh, yes, you will.
Yes, I will. And so also, to deliver the benefits of object storage to the traditional apps that aren't coded for objects, right? They don't know how to talk the S3 interface or whatever. And of course, that helps eliminate forklift upgrade. It keeps scaling out a node. Just Adam, Doug walked us through the kind of the scale. Scale the web scale way. Enables us to do data protection without relying on RAID for that. And so we actually eliminate all the complexities of RAID because we allow drives to be bought at commodity
What's the
pricing.
minimum cluster size?
One node.
One node
So,
with
yeah,
two
with-
drives?
One node with 3 drives.
3 drives.
We'll land the 3 replicas across the 3 drives. And then from there, you can go to 3 nodes. 1, skip 2, go to 3, and then 4, 5, 6, all the way on up.
And then what's the maximum cluster size?
So today, 7 nodes.
7
and
nodes.
growing. Yeah. So we're talking, half petabyte size problem space, which is another differentiator from the other object stores. And obviously,
that's a
growing.
tested, not a design limit, right?
That is not a technology limitation. So I'll cover that a little bit. That's really a market that we're addressing, and you need to buy a lot of nodes and put them in the lab too. And we've got a pretty small lab back there, so we're working on that kind of stuff. So RAID-free self-healing for multiple drive and node failures. RAID can handle drive failures. RAID can't really handle node failures. So with our scale-out technology, you can lose 2 nodes without data loss, right? And continue running. That's up to 16 drives, by the way, right?
2 nodes out of a 1-node cluster, or 2 nodes out of a minimum 3-node cluster.
Exactly.
If
so
you could manage to lose 2 nodes out of a 1-node cluster, I'd be impressed.
with 3 or more nodes,
And you already
can
lost
lose
it,
2.
Okay.
Obviously, if you have less than 3 nodes, say if you have 1 node, you can lose 2 out of the 3 drives. And then it's equivalent to RAID in that RAID 6 in that
So you're
sense.
replicating each deduplicated object
Exactly.
3 ways.
Yep. So we dedupe it and then we replicate it. And I'll actually talk about that, the technology stack a little bit later. And then finally, this whole idea that, ability to scale from terabytes to petabytes tomorrow without having to, change out the technology under the hood, and to make it super, super easy. Right. How do we differentiate against some of the other object stores? Other object stores are really good at certain NAS workloads when you add a NAS gateway to them, and they're really good at object workloads at scale. We're talking tens of petabytes typically, where they start to hit their sweet spot. We covered the other half from the up to that size, right? And we're just moving up market slowly there. And then also we carve off the NAS workloads, and we take it as one of our key technology areas is that we're going to make all the NAS workloads work really well. So tight coupling. If you look at us in terms of our architecture at a little deeper layer, compared to some of the other object stores out there, we use about the quarter of the memory per terabyte of capacity under management. So the other guys are much, much bigger. And then ease of use, right? These other guys, and I just show you an example up here. I'm not going to name any names of other vendors, but if you want to deploy a NAS type solution with another object storage vendor, first, at this scale, they're not even interested, right? But just to give you an idea of the different starting points. You're talking about
won't
8
even sell it
nodes.
to you for less than a petabyte.
Exactly. If you're less than a petabyte, and this is going to be less than a petabyte deployment, they're not interested, right? But you got to at least have 8 nodes, 2 controller nodes for high availability, 2 gateway nodes for high availability in your NAS gateway. So your get started is a minimum for even a proof of concept is going to be 12 nodes. Compared to us, that's 1 node, and obviously the dollars.
You say a quarter of the memory needed per terabyte. You're talking about metadata memory kind of?
No, so this is RAM per
or
terabyte
caching,
capacity.
or for
per capacity. So if you look at Ceph or these other guys, they'll say something like, if you look in their details about their specs, about what do you need in order to run this, they will say something like, you need a gigabyte of RAM per terabyte of capacity. So per terabyte of usable space, they need a gigabyte of RAM. And so that's actually, we think it's excessive, and we're able to do our stuff with less. And by the way, that Ceph number, that's very common for many of the object stores. That's not unique to Ceph.
I would say that's not necessarily evident on other object storage systems that we've talked to of late.
Okay. Well, that's
Ceph maybe, yeah. I agree.
Yeah. Obviously, I don't have a lot of data on the proprietary details about other commercial ones. So
I would say you're the first object storage vendor to talk to that level. I would.
Sure. So the rest of the talk, I'm going to talk in kind of 3 segments. That was the kind of the high-level overview.
Can I ask a quick question on just drive failure and
Sure.
the previous discussion?
Yep.
It was If you were to move a drive from one node to another, does it use the existing data on there?
Yes. Yeah.
And if you were to put a drive in there that already has some data on there, but it wasn't originated from this, does it purge it, or what does it? Does it? You have to import it and give it the option to destroy it, or something.
So we label every one of our drive with a unique identifier that identifies the ring it came from. And so if you insert a drive from, I'll take the second question first, right? If you insert a drive from a different ring, what we're going to do is we're not going to start writing to it. We're going to generate an alarm in the management system, so you'll get a notification via email and say, you got to make a decision. Are we reformatting this, or are we ingesting the data, right? And because the drive may be encrypted, you might have to enter your keys if you're going to be able to do that, right? If it's not a disk from one of our rings, we'll reformat it.
Okay.
Right, and so the assumption is if you've plugged in, a drive that you had laying around or that you're using for something else, it's not in our format, we're good to go. But if you plug in a drive from another ring, it could be you're trying to migrate data, right? And then we will ingest and we'll rebalance that data around the ring, and then start using the available space.
So if you have a node failure, you could take a bunch of drives from one of the rings and toss it into a new one, and it says we're ready to roll with this.
Yeah, and so that's actually
so all the drive metadata for the objects are all resident on the same drive as the objects themselves?
I'll get to that in the end of the kind of, I'm going to walk down the software stack from the bottom, but just at the very high level, we locate, when we write data to a drive, we write both the info about the metadata about the object as well as the object itself. And then it'll be replicated onto 3 drives. It'll be in different spots, unlike RAID, on those 3 drives, right? Because they're just, each drive is considered as its own little mini shard of the object store.
Yeah.
And so on. So